Um, okay, so I will start the presentation. Good morning, sir, and good morning, friends. Today, Ezra and I will present about the Milestone 3, which records the progress report of our PCR project. And first, to recall the previous research problems, first, the functionality of the chamber has never been tested, and the CNT sensor is inaccurate due to lack of calibration, and the resistance is also unstable. As for CNT as heater, it is unable to reach the desired temperature because of high resistance, and the nichrome wire is also unable to accommodate temperature change because of low resistance. And the idea for improvement, first the chamber, but we will change the design to optimize the microfluidic properties. And for the sensor, the cnt-thread will be braided, calibrated, and characterized properly. It will also be sewed onto a piece of carton. And for the nichrome wire, the wire will be coiled in order to increase resistance. The procedure is the same as we have proposed before. First, we make the components, the microfluidic chamber, the cnt-thread sensor, cnt-thread heater, and also the nichrome wire as heater. Next, we will test the components by testing the hydrophilic and hydrophobic characteristics of the chamber, and then calibrating and characterizing the sensor and testing the heater. And then last, we will arrange the components by creating the casing and assembling the components with the casing. The materials is also still the same as we have proposed in previous paper. Now for fabrication.
So now we're talking about the fabrication. So there are three things that we already did. The first one is making the microfluidic chamber, and also the CNT coated thread as sensors, as well as making nichrome wire as heater. So first, the microfluidic chamber fabrication. There are several steps that we have done. The first thing is that the chamber design was printed in the Silhouette printer and using vinyl sticker paper. And after that, the hydrophilic part were stuck to the scored cotton fabric. So we just layered the hydrophobic part. And then the third, after we already make the design in the cotton fabric, then we make the solution, which is mixed by mixing epoxy resin and hardener with the total ratio of 1 with a total of only 2 grams. So the solution was really it has a small amount of solution. And then the fourth one is the mixed epoxy solution was poured and layered to the hydrophobic part. But the step is really hard because the properties of the cotton, so it can the solution can like diffuse to the hydrophilic part, so we have to be really careful. And after that, we dried it for 16 hours. Next is the step to make CNT coated thread as sensor. So the first thing first is we created the CNT solution is by mixing 5 grams of CNT and with the 500 ml of distilled water, and then the solution was sonicated for 30 minutes in the 30 degrees Celsius, and then after that the solution was stirred using magnetic stirrer in 60 stir for 30 minutes. And then after the solution was made, then we go further to make the CNT coated thread. So first, to make the thread, we combine three 30 centimeter threads, and we braided it into one strand, and then we put the to the solution, and it was sonicated for 10 minutes, and then the thread was taken and put into oven for another 10 minutes at 60 degrees Celsius. And after that, the resistance of the thread was checked, and we want the thread to have a minimum like 2K until 10K of resistance. We repeated again the steps until we obtain the desired resistance. And after we got the desired resistance, then the CNT coated thread was sewed on a 4.5 centimeter times 3 centimeter carton with a zigzag pattern, where each line of the zigzag has a length of 0.5 centimeter. Next.
Next, for the nichrome wire as heater, the nichrome wire is 2 meters long. It is the nichrome 80 specification with 36 AVG, and it is coiled with the help of a chopstick with diameter approx 0.3 centimeter. After it is already coiled, the wire is attached to a piece of carton held in place by cotton thread sewing.
So now after we already did the sensor, cnt-thread sensor, we did the sensor calibration to make it. Next. We made the circuit as the A and B, so we tested it with the two different sensor. The first one is NTC W1209, which is already calibrated, and also the LM35. First, we combine it. We compared. We want to calibrate the LM35 to the NTC W1209, and then after that, we compare the LM35 to the sensor. We did this because we want that the LM to have we assembling the circuit, so LM also have the ohm meter, and we already calculate the sensor and also the resistance, so we can compare the resistance between each other. So we made the code like this, as the in the calibration test. Next. So now we will discuss about the results and discussion. So next, wait, yeah, this is the video. So wait a minute, Anjali. So the upper part in the right side is the chamber before the test. So these are the chamber, and we folded it until it become like a square like this with the size of 3.5 centimeter times 3.5 centimeter, so it's like square. And then we did the experiment. Angelique, can you play it? So we put the solution, colored solution, to the chamber, and then even though it's not really clear, but it can be seen that there are water mengalir, flows to the hydrophilic part like this, and the result will be like at the bottom. So there are no water flows to the hydrophobic parts, but water just flows to in the hydrophilic part. Next. So that means that the microfluidic chamber is design is success. Next. So now this is the CNT coated thread that is sewed in the carton. So these are the design, and when we measure it, the sensor have the resistance of stays in 5.6 or 5 kilo ohms. And then when we test it for the calibration, the sensor resistance cannot change. It is too stable. Um, we have a hypothesis that maybe the stability of the resistance is caused by the medium of the CNT coated thread sensor. Um, because we use carton, and carton is basically an insulator. So the heat cannot transfer well to the sensor, so the resistance is slowly changed. So that's the problem of the sensor right now that we found. Next.
Next, for the nichrome wire aceta, this is the result after it has been coiled and attached to a piece of carton. So to test it with heat, it is connected to a 12-volt battery by attaching the clip here on each end, here and here. And it can be felt by touching that the wire gradually becomes hotter, showing that it can conduct heat properly. For further improvement of our project, first we will change the CNT sensor's medium from carton, which is an insulator, to aluminum sheet, which has a higher thermal conductivity. As for the calibration of CNT thread, the sewing of the thread will not be as tight to make it slightly more unstable, and the characterization of the CNT thread will be done once the calibration step is complete. As for the heater test, aside from testing that the wire can conduct heat, we will also note down the highest temperature that can be reached by the nichrome wire and the time taken. For the combined heater and sensor test, the cnt-thread sensor will read the heater temperature, and the NTC W1209 thermistor will be used as sensor control. For the fabrication of casing, the carton will be used as the material, and it will be colored using pillows. This is the Arduino code that we prepared for the characterization of the CNT thread. And that is all. Thank you.
Thank you.
Okay, thank you, Ezra and Anjali. I would like group 2 to ask some questions for Ezra and Anjali.
For the microfluidic chamber, could you show like the flow, where will the liquid flow starting from when you drop the liquid and then to the bottom? Itu kan there are
Okay.
layers gitu.
Okay. The upper part is the 3 dot like here. So ini nggak bisa annotation. Oh, bisa ya. Wait. This part will be for the primer. This is for the DNA, and this part is for the PBS. So after we put it one by one, then so actually this have the shape like this. I'm sorry.
Yeah, perhaps the chamber you can draw the schematic, ya, apa namanya? The drawing, the schematic drawing, cross section and also top section, so that it will be clearer how the liquid will flow.
Wait
Not
a
only
minute.
only the actual photograph, but also the design, the schematic design. Maybe if you have it, you can also share that with us, so it is clearer then where actually the reaction happens, where are the sample introduced, where are the primer being introduced.
Okay, sir. Actually, I already made it, but wait, I'll share it.
So I'll stop share.
Boleh. Yeah. So, can you see the share screen?
Yes.
So yeah, the primer is here, and then the DNA is here, and PBS is the green part. So when we pour it, the primer will flow, and the DNA will flow to this, and then gradually they will mix together in and gathered in the this circle. And after that, the PBS will already flow to here. However, they will menembus 2 kali. What is it called?
They will wick twice through the second
Yeah.
layer.
This is the second layer, and this is the third layer.
So the mixture is at the third layer with the BBS.
So after it was mixed in here, the mixed solution will be combined with the PBS in here. So gradually, what we really want in the future is we put the electrodes is in here, so we can measure the DNA in here. So that's the.
I have got why the PBS not mix at the same time with the primer and DNA in the second layer? Is there any particular reason?
Because they have to mix it together first. So I made time by making these 3 layers. So mengalirnya tuh lebih lambat gitu. Kalau misalkan belum di mix, kalau misalkan cairannya belum mix and jadi, that will there are no use of mixing the PBS like that. I think.
Okay. Is it from DNA PCR reaction has to be like that? That the PBS is mixed the last after DNA and primer mixture.
Yeah, I think the PBS is for like apa ya? The last step karena kayak gimana jelasinnya? So first the DNA has to be has to react with the primer first, and PBS is the last step because kayak PBS tuh kayak sort of dicuci. What do you call it? I forgot. This oxygenated.
So where does the reaction occur? The annealing, denaturation in the third layer.
In here, third layer.
Yeah, it's because it's gonna be square like this. So the third layer, the mixing part will be in here in the third layer. So yeah, the denaturation and other steps will be occurred in here. However, because the PBS is in the third layer also, so the flow will be very slow. So that will create the denaturation and other stuff will can conduct first, and after that, after it reach this part, the third layer, then it will combine, and the electrode can measure it.
Other
So
questions
it's
from
about
group
time.
2? Andy, maybe? Grace, are you satisfied?
Ya nanti mungkin at the final presentation I could see the real application.
Yeah.
Kan it's not yet finished.
So yeah, actually the idea for group 1 is that for this, for the sensor and measurement, to finish until you can prove that you can heat up the 3 stages of PCR in a test water resource. Not yet to do actual PCR amplification, but to prove that you can heat up that mix in the third layer or second layer, whatever, at the 3 different temperature, 95, 65, and 72. That will be the goal.
Yes, sir.
Andy, any question you would like to ask?
No, I guess.
No question? I think your group mark for asking.
Actually, I wanna ask about, I think, aluminum sheet. Is it what actually it is?
Yeah, it's a sheet made of aluminum. So actually, we're discussing with Kasem, and he said that um, in the lab there are aluminum sheets. So maybe we can change it, the medium to the from the insulator to the thermal conductor materials.
Yeah,
So
this is
maybe
also
it
the
will
point. The
change
point
it.
which I also do not understand why you need to change it, because the
Uh,
cnt-coated
we
thread is function as what, sensor or heater?
sensor. However, the sensor is too stable. At the previous problem is the sensor is very unstable in the previous
What do
study.
you mean here?
However,
Unstable,
for
stable.
us, the sensor is too stable. So when we heat it, it's stuck in the 4K and 5K. The changing is too
Slow.
yeah, too slow. So we're still searching why it's happening. So we're just testing whether is the medium really affects the resistivity of the sensor or something. But actually, we still don't know. It's just a hypothesis. So we have to test it first before yeah, we conclude that because of the medium.
Yeah. Perhaps you can ask around to Pak Fatoni about the physics there, because you want to measure the liquid temperature change, right, in that layer, right? Yeah, that's why, of course, ideally your cnt-coated thread sensor has to be inside that fluidic channel, inside the channel, ideally, but it will short circuit. It will make it short circuited, because the water will be conductive, right? So it means you have to put some insulating layer. So your cnt-coated thread is not inside the channel, but rather it is attached to the fabric channel, right? Attached to it, so that it can measure the temperature change there. Attached to it, however, why do you need to really have that zigzag? Because your fluidic channel is also not that big, right? I mean, what is the length? What is the width? Can you share again your figure?
I didn't understand what your question, sir.
Ya makanya share again your PPT.
Okay.
I will make it easy rather than ngawang-ngawang kayak gini.
Ada PPT.
Share your purpose presentation. Yeah, so eventually your reaction will happen here, right?
Yeah.
So you have to put your sensor also in the vicinity of this. Correct or not? Because you want to measure the temperature in that chamber. But so yeah, paham nggak? You understand? What is your? My question is, what is your where is actually your reaction chamber? This one, right?
Yeah.
Our reaction, in the circle that you draw. So.
Yeah, that's why your sensor, whether it is nichrome or CNT, your temperature sensor has to be attached to the chamber, because that is the temperature where you want to detect. So going back to your design of the temperature sensor, which I don't understand why you need to change the medium. The medium doesn't have any consequences there. I mean, go to the slide where the your sensor design.
Sensor.
CNT coated sensornya, mana desainnya, tunjukin. Bukan microfluidic chambernya, not the microfluidic chamber, the sensor.
What?
Yeah, where will the sensor attach to?
Di bawahnya. Under
To?
the under the apa tuh namanya? Itu.
Chamber.
Yeah,
Under the
first is the size doesn't fit, doesn't match. Your microfluidic chamber is smaller, much smaller than this. But this one is so large. How come you make the sensor so large? Well, what you want to measure is only a small part of the chamber. The size. Makanya, it's always wise when you draw something, when you put to the presentation, you have to put a size scale. What is the size here? 1 centimeter or 1 centimeter? Yang tadi juga. And the previous slide also, in the microfluidic design also, what is the size? Show me the previous slide.
Oh wait. This one.
Yeah. Similar also, what is the size here? How many centimeter? 1 centimeter, 1 millimeter, or what? Don't just put the figures without any indication of the size, but also you need to put the size scale. So you see here, if I see, what is the size here? I ask you. Quick
Yang
answer.
mana, sir? Yang mana?
Ini size-nya berapa? Ini size-nya berapa? That's my
Oh,
question.
itu. 7 centimeter, sir.
Yeah, okay. This one box is how many? This one box is how many?
3.5.
3.5 centimeter. Okay.
Yes.
So more or less, this one will be about 1 centimeter only. This one, the reaction chamber is only 1 centimeter, right?
Yes.
Okay, clear. Next slide. So now what is the size of this one?
Belum muncul, sir. 4.5 centimeter, sir.
4.5 centimeter. How come it is so large? While the temperature you are going to measure is only maybe 1 centimeter, yeah, from the previous slide, right? Only this slide. So mismatch, right? The design.
Okay.
You are not going to use this temperature sensor separately to measure temperature outside the room. No, you are going to use this to measure the temperature at the fluidic chamber, at the PCR chamber, reaction chamber, right?
Yeah.
Yeah.
Why doesn't it match the size? The size alone doesn't match.
Okay, maybe it's one of our mistakes. We will try to
That is why
fix
before
it.
you operate it, before you fabricate it, do the correct design first. The whole design, where it is chamber, because you are not only making microfluidic here, because you also need to put the heater there. You need to put the sensor also there. Go to the previous slide again. So it is not just like this finish. No, you need to put heater there, and then you need to put sensor there also at this chamber.
Okay.
So where are you going to put those sensor and heater? Near that chamber. The heater is used to heat the liquid. The chamber, the sensor is to detect the liquid temperature there. From there, that you can then put into Arduino to regulate the temperature. Jadi sistemnya itu bukan sendiri-sendiri. They have to be subsystem of the whole of a single system, this PCR system later. Your goal within the subject is to prove that you can regulate the temperature of that liquid inside that microfluidic. Not yet to DNA, real DNA application yet, not yet. But to regulate that, the temperature has to be able to be regulated to 95 degree, 5 degree, and 72 degree. So now it's already third milestone. You should already get them in as an integrated system. How? Ini kan belum, ini masih separated. Microfluidic separate, you do separately, sensor you do separately, heater you do separately, Arduino you do separately. But then how you are going to combine is not clear yet. You understand?
Yes, sir. Yeah.
Yes.
Yes.
Okay, so please correct. Yeah, this is uh, either you enlarge a little bit the fluidic chamber, but then it will cost you more power to heat up, or you miniaturize the heater and the sensor. You don't need that large zigzag thing. You have to make it smaller. Maybe you don't need to make it as a braided thread sensor. Yeah, rather than a single sensor will do. The problem here is that it is high temperature 95 degree. So your sensor should endure that high temperature without breaking. Also the heater also. That's the only problem from the previous group also.
Okay.
Okay, sir.
Clear or not clear? Or you have
Clear.
things to ask?
Um, no, clear, sir. We have, yeah, we have to change some designs.
Okay, yeah. Any further comments, inputs from group 2 maybe?
Yeah.
Sir.
No comments? Okay, if not, then let's proceed forward to group 2. Thank you very much, group 1, for the presentation. Yeah, please
Thank you,
take into
sir.
account these inputs. So we want a working device, not just for the sake of presentation. Yeah, for the sake of presentation, yeah, separately it will do, but we want it to be integrated as a single device.
Okay, sir.
Okay, sir. Thank you.
Thank you, sir.
Okay, group 2.
Okay, good afternoon, Padidi and friends. So today I and Andy will be presenting about our project, which is the contactless temperature sensor based on CNT coated thread IR absorber. First is the materials and fabrication. So I'll just go fast at this part because yeah, it had been presented at the previous milestone. So these are the materials that we used, and some are obtained from SGU Lab, some are bought from Tokopedia, and for the bolometer casing, it's fabricated in Spain. First, for the fabrication is the MWCNT-COOH coated thread. Yeah, so we need to fabricate it again because the ones in the SGU lab has a high resistance. So first we start with the thread scouring with sodium bicarbonate, and then after the scouring we will braid the thread. So the 330 centimeters thread will be braided with to each other, and then we prepare the MWCNTCOOH solution, and then we coat the thread by sonicating it inside the MWCNTCOOH solution. And then next is the HBN, NBN, or PVA solution. So we extract the BN sediments from the HBN dispersion, and then one is mixed with distilled water. That's for the HBN solution, which is inspired by Kak Christo's paper, and one is will be mixed with the isopropyl alcohol, which is our own innovation, so that um, we want to test whether it could absorb more heat or not using the BNPVA. Then after that, they were sonicated, and then they were centrifuged at 5 degrees Celsius at 3000 RPM for 15 minutes. And then vacuum filtration is done to separate the residue and supernatant, and the supernatant will be used to coat the fabric. Next. And then the cotton fabric coating and stitching. The cotton fabric is made at a size of 2 point. I think if I'm not mistaken, Andy, it's 2.3 centimeter kan?
Yes. 2.3.
Yeah, 2.3 times 2.3. So it's square. And then first the fabric will be scarred using sodium bicarbonate under the same procedure as the thread. And then after that, the cotton fabric will be immersed inside the HBN solution and the BNPVA solution. So there will be three types of cotton fabric that will be tested. One is the bare with so we didn't immerse it on any solution at all. And then after that, after immersing the coated fabric, we stitch the thread onto the fabric under this arrangement. So this is the size. I think it's not clear enough. Yeah, but we followed these measurements to stitch the thread.
As for the results of our experiment, so the first photo at the top left is the fabric that we use, and the right one is the result that the fabric there that is not coated with anything. The fabric was coated with BN and fabric coated with BNPVA, and this is the result after stitching too. So there is four measurement. The first is the resistance of the thread before stitch, after stitch, and then the temperature test, which uh, which is high temperature and low temperature test, and the thread that were made, we search for the resistance near 20, and luckily we have 20 around 21 around 21 kilo ohm, and there are three of them, uh, and this is the result of their stitch, heat, and coat that will be displayed after this. So the left one is
Slowly. Not yet. Slowly. Previous slide is. I'm trying to understand.
okay. So actually, as you
Explain
can
the table. Yeah. Explain the table also.
as you can see, there are a huge increase after the thread uh, after the thread were stitched to the fabric, and it is a really huge increase in the resistance for the normal NB and PVA, while the BN1 has really low compared than the others.
So this is
And
the resistance of what?
the resistance of the thread, as you
Of
can
the
see,
thread.
the thread that is what
Okay.
can you say, normal, and we measure it right there. And for the heat, it shows not good. It shows
So what does it mean with heat and cold here?
so we do experiment using 4 40 degrees Celsius
Yeah,
water.
that's what I mean. Yeah, you have to make it quantified as number. Heat is at 1000 degrees Celsius. Cold is it minus 77 degrees Celsius. What degrees is this? How you are doing it? Have to be clarified. Yeah.
I intended to explain it while playing the video, sir. Sorry.
Yeah, but also the table. No, you don't put heat cold like that. You just put.
Oh,
You have to put a quantitative
okay.
number. Yeah. Cold
Okay.
is also heat basically, only less temperature.
Okay, sir. Uh, so as we can see, this is the result. For the high temperature, it shows a lower result from the after stitch resistance, and the cold, and either do the cold, which is it's not uh what we're what we were expecting for the normal. As for the BN, uh
Decreases. Yeah.
yes, sir. And it is both of them, not only just the
With,
heat.
with, with BM, with cold, it increase.
Yes,
With
sir.
resistance increase, with heat, resistance decrease. With
Yeah.
BNPVA, both resistance decreases with
Yes.
either heat and cold. Although with cold is just very small decrease.
Yes, sir. And uh we will show the video that the experiment that we've conduct, and the video was fast forwarded 2.5 times faster for the sake of time. As you can see, there the resistance doesn't show a stable resistance even at even while we were doing nothing. And this is an ice pack we used for the low temperature, and this is the beaker, the water we used for the heat. And as for the BN coated fabric, as we can see, the the resistance is really unstable, and we try to confirm the temperature test with the same method as uh, all of all of them. And there is actually an increase, but after that it decreases. So it doesn't show reliable result of resistance change. As for the last one, the BNPVA coded, it shows the same result. It is unstable and doesn't really react with temperature. Okay, so let's move on to the problems and analysis.
This is the problems that we face while doing the experiments. First is before the stitching. So actually, it's not the supernatant of the HBN that should be used. It's actually the one that should be used is actually the residue. But after centrifuging and doing a vacuum filtration, there is no residues at all. So like no residues were formed, and I think we think that this is caused because the one that we use is the HBN dispersion. Actually, Kadef or I forgot who. Somebody said like it's actually we don't use the HBN dispersion. We use the HBN dispersion because it is affordable and it has a lower cost gitu. We should use the HBN flakes instead of the dispersion because when we extract the sediments it's like still in liquid form, itu kayak it has a high viscosity kayak kental gitu. And then second is the resistance of the threads varied. So after we cooled with the CNT, we measured the resistance of each thread, and then it varied like there are some with 14 kilo ohm resistance, there are some with 30 kilo ohm resistance, some with the 20s. And I think that's because of the coating weren't equal at all part of the thread or nor with in different threads. So it produces a different resistance, and also this thread is also sensitive. Like I mean, when we touch, there is our hand turns blackish. It means that the CNT coating peeled off, and that's what caused the increase in resistance or the resistance instability. So that's what we face prior to the stitching, and after the stitching, it's the different there are different resistances produced, and the resistance was barely stable. So as we could see from the table earlier that has been explained by Andy, so the resistance produced after stitching, like there are the BN1 there is around 34 kilo ohm. For the BNPV it's around 100, and they are different. And then it took a lot of time for the resistance to be stable. Kan if it's not stable, then later the temperature measurement could also vary. So stability is very important here. And then for little movements cause significant resistance change. Like for example, if we move the cotton a bit, the resistance will change drastically. Like I think it is more resistance to movement rather than to temperature. Fifth is it's not sensitive to temperature, like what I have explained before. Like it is more sensitive to like pressure. Like when we press it, then there will be a drastic resistance change. But when we expose it to a certain temperature, the temperature change is not reliable, and it's very little, and it's hard to tell whether it will produce a correct measurement or not. So that's all for the problem. Next me.
Well, basically, for the factors affecting the resistance change were explained by Tanita for the movements and pressure. As for the external factors, okay, so for the movement and pressure, yeah, as she said before, when we put a pressure to our sensor, the, it is much better. There is much better resistance change, uh, better than the temperature test, temperature exposure. Uh, as for the external factors, perhaps it it was affected by the uh, temperature surrounding the sensor. As for the contact with thread, as she said before too, when we stitch the thread to the fabric, it it ngelupas the MWCNT, which makes our hand blackish. And from these experiment, we doubt that MWCNT coated thread can be as a thermistor. Why? Because it is too sensitive to any movement or pressure. So uh, when we do the temperature test, I mean, like when we want to do temperature test, if there is movement or pressure applied, it will change the resistance. It is not stable, as we can see from the previous. The thread must placed in a rigid media, uh, and the thread must be isolated, which is the same with the previous Ka Christos experiment.
So what is meant by Andi by placing it in a rigid material so that if we know if cotton fabric is very flexible, like if we move the cotton fabric or fold it a little, then the structure will also change and it will also affect the thread. So yeah, I think it will be better if we place it on a rigid media. And then also the thread must be isolated so that we will not have a direct contact with the thread, so that the CNT will not peel off, or yeah, other kind of factors that will affect the thread's resistance. So after seeing the results, we try to make a certain improvisation, but we didn't took picture of our improvisation. So we use two jumper wires, and we make it kayak dideketin, and then we roll the cotton thread around the jumper wires like this, like what Andi have shown, and then we try to measure the resistance of the thread by measuring the other side of the jumper wire. So we kayak dikelupas di sisi yang lain, and then we measure it with the multimeter. But then the result shown is that the resistance isn't measured at all. So yeah, it became a new problem. Also
Yeah,
for
of course.
yeah, so
Short-circuited.
so yeah, for the we will try another kind of improvisation if it doesn't work in the bolometer. Next, and then
Uh, so for our conclusion based on our experiment that we've conducted, uh, our sensor that we made is unreliable, uh, because they have bad resistance change. Even it is unstable, and we think that it is better if it is applied on mechanical system, bec- uh, because the temperature change for the pressure that applied is really nice, better, well, way better than temperature exposure. And for the further things that we will do, we want to prove these statements. Is it really is are we can't make it as a sensor or not?
yeah, so to prove the statement that and that we said like kan at this milestone we conclude that okay, it is not feasible to be used as a temperature sensor, but actually we haven't finished our experiment. Like what I have said earlier, like I think it would be better if we isolate the sensor so that it will not be touched, and then there will be no external factors. So we will still continue our experiment by placing the sensor inside the bolometer, and then after that we should ensure that the sensor is glued tightly so that there will be no other movements, and then also we will since actually the first phase of the experiment, which is the one yang we measure the temperature, is to see whether HBN, BNPVA, or could give a certain effect on the resistance change. But I think we
Quick,
failed
make it quick
to prove
because
that. So I
we
think
need
we
to
will
press.
make another
Okay, understand.
another fabric with code.
You don't have much time. You don't have much time. Okay.
Yeah.
I
With the
understand.
coating.
I get it. I get it clearly, but
Okay.
it is
Yeah.
quite disappointing actually the result. Yeah, because I think your experimental setup is not made carefully. It is the experimental setup. Show again. Yeah. Of course it is. They are sensitive towards strain, but I think it is more that like this. It is floating. Everything is floating. There's a contact. It could also change due to the change of the contact resistance between the clipper and the sensor. That's why when you move a little bit, the resistance change. Yeah, the resistance change is due to that this contact most of the time. If you mention that it is not stable because of this contact, so you cannot just conclude like that. Oh, this is bad. This is bad. Well, you are not controlling the experiments carefully. After you control everything carefully, the experiment you control carefully, and you make sure that there is no effect of this factor, then you can conclude that it is bad, that it cannot be used. But don't jump to the conclusion that the thermal system, what the previous group proven, they proved that it can be used as a temperature sensor, as a thermistor. Right? Because they have careful setup. You have to ask them how they make their experiments, their setup. Jangan asal buat setupnya itu gitu loh maksud saya. You have to make it carefully. Kalau perlu you put the fabric in a stretch manner that it cannot wiggle, it cannot floating around. You make sure there is no convection surrounding the setup, because the temperature can also change due to the convection. You blow a little bit like that, it may change the resistance due to the convection from your blown air. It is a very sensitive. Yeah, it is. You have to understand this cnt-thread is a sensor that has cross sensitivities. It is not selective. It is sensitive also towards strain. But I don't think that like this only by wiggling then the resistance changes a lot due to strain. The strain is really that you pull it, or you bend it like that, then the resistance will change. Most of the time, it is due to the uncareful contact, because you attach directly the thread to the clipper of the multimeter. You have to use for example, a copper wire or a gold wire. You clip to the clipper, and then the other end you solder to the cnt-coated thread. You solder or you wrap it around, so that you make sure that there is no changes in the contact resistance. Why do I know that? Yeah, because I did this type of experience many times with my students, PhD students, master students, undergrad students. Yeah, most of the time, most of the problem come from the contact resistance change. So you have to make sure it is completely soldered. The contact of the measurement with the sensors is completely soldered. No wiggling here, because if there is a wiggling, there is a gap changes, it will change the resistance significantly. So the wiggle can happen in the clip on the other side, which then doesn't change a lot because they are very, very conductive. Yeah, so come back to the original idea that the fabrics is used as the infrared absorber. So not as a contact thermal transducer. Okay, not as a contact thermal transducer. That's why they are used as HBN and SPVA as infrared absorber. So no direct contact should be put with the cold or with the heat, with the hot objects to the sensor directly, but instead from a distance, from a super distance. Yeah, the direct contact can be made to the cnt-coated thread itself. The cnt-coated thread itself will function as a contact thermal transducer, contact temperature sensor. It may or it may not be sensitive towards infrared absorption. We don't know that characteristic yet. So to increase its infrared absorption, it's why we stitch it into fabrics. And to increase further the infrared absorbance, it's why the previous group used HBN, boron nitride, because it has good dielectricity property. Dielectric phenomenon, dielectric property. With the dielectric property, you can increase the absorbance towards infrared. Yeah. So that is then how the experiment to test each of this stage carefully. You have to design it carefully. For example, first, without stitching first, the cnt-coated thread, you have to test in proper manner. Put it inside refrigerator, for example, with what temperature? Put it inside a heater with what temperature? You don't do contact. You don't put it attached with a beaker water like that. Of course, then many things can happen there. The contact between the multimeter clipper and the cnt-coated thread may change. What else? There is air being blown away. Yeah, of course, many factors can occur there, and it means the experiment is not scientifically carefully designed. The same with the previous group. Yeah, pikir dulu. Think first before you do the experiment. Yeah. Think first. What is the principle being applied there? Okay. This is what makes us different than high school. In high school, they just do experiment. Now you have been taught all these theories in physics, in sensor and measurement, in biomaterial. So you have to use those theories. Theories itu bukan untuk sekedar ujian doang gitu. But for now, for project, that is why I like project, because you have to learn to implement the theories that you have learned now. And you have to explain the result also using theories, bukan hanya bla bla bla. Langsung jump to the conclusion. No, it can be used. It cannot be used just because. Yeah, because it's clear from the video, also clear that the experiment is very rude, roughly designed. No careful design. How is the attachment is made? Make a simple setup using clip whatever, using simple, but it is carefully so that you make sure there is no movement of the sense of the fabric itself. You make sure that the fabric is not being stretched when you attach something, and the temperature stimuli also should not be given by like that. You put into a thermal chamber and you measure the temperature carefully. So not you put as heat and cold. No, you put the exact temperature. What is the temperature you apply there? So that you can draw the calibration curve later. Yeah, this is the effect of not doing lab for many semesters. You lose that sense of experiments. Yeah, it's the problem now. It's due to the pandemic. I do not blame you all for this, but for this result. But yeah, please learn from this result. That it means, yeah, I don't think the previous group did their temperature experiment like this, like what you did now. No, I thought they've done it more sophisticated, with more sophisticated design. Even though it is not their own design, they do the design, but the one that is doing it is Samuel Andrew. So you can ask them why can you not ask them? Ask them how they do. Yeah, ask for them for their experience. Jangan kalian kira-kira doang terus tapi eksperimennya ngawur kayak gini. Maksudnya kayak gini, attaching the beaker directly. Yeah, of course, it doesn't change only the temperature, it changes also the connection, the connection between the clipper and the sensor. Of course, beaker also will move. Dan ya gini kan kayak ini clip ini sensornya si integrated clip. You move a little bit, it changes the resistance a lot. Use the first digit and second digit from the right, it change a lot because there are many gaps. Itu kan bentuknya juga bukan, it is not completely like this. There are air gaps between, and that contributes to the metal to the contact resistance. Okay, so please think carefully. Think the design carefully, then conduct the experiment carefully with steps, with quantitative, not just qualitative. Hot, cold, hot, cold. No, measure the temperature. We have temperature sensor right in the lab. Use them, and use your knowledge of electronics also there. Then, after you see the result, analyze carefully also. Use the theory. Use your analytical mind to think what actually happens there. What actually can be the cause. Don't jump directly to the conclusion. No, it cannot be used. Okay, question from group 1.
About the temperature sensor. Untuk yang ngukur sensor, untuk ngukur temperatur, I asked Pak Kak Rizal, and there is no temperature sensor that is like not contact. I mean, di sini kan kita nggak ngetempel itu beaker, tapi kan ada heat di bawahnya. Jadi kita tadi itu pengen ngukur temperatur itu, cuma nggak ada alatnya Pak katanya.
Ya memang bukan ada alatnya, but what I mean is you measure first the temperature of the beaker. How much is it? How high is the temperature?
40 degrees Celsius.
Are you sure? Other than, why don't you put it first? You characterize first as a thermal conduction. Because later, if you want to measure infrared absorbance, you cannot do also with the air surrounding it. You have to do it in the bolometer setup already, inside the casing. Can you learn from physics, right? There are 3 types of heat exchange: conduction, convection, radiation. And we want actually to use it only for radiation. Tapi jangan langsung gini, Raf. Langsung ditaruh di atas ada nggak gini. Ya, kan ada pengaruh dari konveksi di angin di sekelilingnya. Kalian gerakan itu beaker juga sudah ada angin. Itu kan sudah mengubah, kan dia very sensitif juga ini di cnt-thread. Gimana? Masa nggak pikirkan sampai ke situ? Oh, ada convection juga di situ berarti.
Mau nanya. For the next improvisation ya. Jadi if we're planning to put the sensor inside the bolometer first, jadi we will make 2.
Yeah, you have to put eventually into the bolometer first, but you have to characterize also the cnt-thread as temperature sensor, the cnt-coated thread as temperature sensor, the cnt-coated thread sewn into the HBN coated fabric as infrared sensor. Tapi yang as infrared sensor ini, you have to do it inside the bolometer if possible under vacuumized condition, similar like the previous group, because without vacuum, when there is still air, it may introduce convection also inside the chamber.
So we kayak make it taruh di dalam bolometer and then we measure. Kalau begitu berarti ujung dari wire-nya kita bakal coba solder ke wire lainnya biar nanti bisa diukur pakai diukur resistance-nya pakai multimeter. Terus kita
Yes, you know how chip an integrated circuit is made, ya. You have chip like this in the middle. The packaging is on the right side. There is what we call as the jumper atau apa. So from here to this, saya sudah jelaskan. I don't know in which course. Baru ini ada kaki-kakinya. Then there is legs there. So it doesn't touch directly to the chip itself. So similar like this one actually. So because contact in electronics, especially when we do microelectronics, contacts play important role. Contacts wiggle a little bit, it changes the characteristic of the resistance a lot because of the gap. Yeah, that is why it has to form what we call as ohmic contact. Ohmic contact means that the characteristic is according to Ohm's law. Kalau wiggle terlalu banyak itu changes abruptly, resistance changes abruptly, it's not ohmic contact. It means it contains a lot of air gaps. Which you can do it like this now. What you do, clip directly to the coated thread, to the CNT coated thread. Yeah, of course, you will have a lot of that things. When you move a little bit the fabric, it will change. But the change is not due to the CNT coated thread, but due to the contact between the CNT coated thread and the clipper of the multimeter. Coba aja lah, nanti coba di lab, buktikan perkataan saya. Nggak usah pakai diker, kamu gerakkan dikit aja itunya, kainnya itu. Ini kan berubah itu multimeternya banyak. Yeah, of course it's sort of, yeah. How do I know? Yeah, because we did a lot already. Experiment with this fabric-based sensor and thread-based sensor. So we know the problem mostly is in the contact. It says you have to solder first with a separate, very conductive wire. Solder or wire, wine around the thread, etc. So that the contact is perfect between them. Dan baru di clipnya itu di contact that conductive wire.
Okay, we'll try that.
This is physics, guys. Physics, electronics, all combined. This is why you learn so many different subjects in biomedical engineering. Without those subjects, you will not understand this. Each of this, why I can speak about conductive, convective radiation, this is from physics. Why I understand about ohmic contact, this is from electronics. And now you're applying it in project. Please implement them. Those things, those theories are not just for books. Now you have to implement them. Itu gunanya project itu kenapa gitu. Kalau kamu hanya pakai written exam, apal tapi nggak ngerti penggunaannya gimana. Sekarang kan kamu tahu. You know now where those theories have to be implemented. You have to use. Otherwise, your brain is not moving. Just stick with the theory, and even during presentation, my presentation, you sleep. No use. Now you have to make your knowledge useful. Yeah, use your analytical capability. This is what makes us different than high school students. High school students, they just do Arduino programming, yang biomedical engineering driven, sometimes very good design, but when we go deeper, they cannot answer. You are students, you are university students. Your analytical mind has to be able to think, why is it like this? Why is it like that? What if I change this? What if I change that? Is this the factor that play a role? What are other factors? How can I control the other factors first, so that I'm really sure that this is due to this. That is university level thinking and problem solving. Group 1, any questions?
Masih ada waktunya, Sir.
Ya cepetan, kalau nggak nanti kalian nggak ada nilai.
Next slide. Yang slide next. Yeah. Why do you want to increase the length of the threads, and what does it use for?
Ya kalau yang tadi awalnya kan mau ngukur langsung tuh pakai krokodilnya, tapi karena apa namanya kita mau gantikan jadinya tadi pakai solder, jadi sebenarnya nggak usah. Sebenarnya increase juga biar lebih gampang aja gitu loh ngukurnya, dan nanti untuk nantinya itu bisa disolder gitu.
Tapi increasing the length kan bisa increasing the resistance juga.
Yeah. It's why it's not the solution actually. The solution is to solder or to wire or to bind it with a conductive wire.
But
Gitu.
actually yang kalau when we see yang after the results that we have obtained, kayak I don't think maybe there is a problem when there is a coating. Jadi yang mau yang panjang mau yang pendek, kayak Andi kayaknya pernah nyoba kan. Yang kenapa yang pendek kok resistance-nya malah jadi lebih gede daripada yang panjang itu. Jadi kayak mungkin kita juga ada masalah di coating gitu. Tapi ya
jadi
theoretically
it is. I think this now the way I see you do the experiment, how you measure this resistance is also tidak bisa dipercaya gitu loh hasilnya. Kemungkinan resistance, mostly the resistance you measure is from the contact, not from the actual thread resistance. Yeah, the contact as I mentioned, between the thread and the crocodile gripper. Jadi increasing or decreasing the length is not the solution actually, because when you increase also, that part may become additional resistance, as I mentioned, series resistance. While you want actually the CNT coated thread, all of them are sensitive towards the absorbed infrared in the HBN fabrics. So the extension, the unstitched part, should be just enough to glue it or to solder with the conductive wire. Ngerti nggak? Kayak anotasi aja. Jadi this is not too long actually, just enough, because you don't want to measure anything anyway from this, right? You don't want this to be an additional unnecessary resistor sensor. You want to measure only the heat absorbed by the HBN here, where you sew the CNT coated thread. So this is the unstitched part, just long enough so that then you can attach to here a gold wire, for example, or copper wire. From here then, you measure the resistance using the gripper, using the crocodile jumper. You understand or not? If you model from because this is your thermistor for the CNT coated thread, if you put too long additional thread, this will be additional RS from the electrical circuit model. This is actually, while you are only want to measure this, if this RS1, RS2 is too large, then they will bury the signal from here. Tenggelam signalnya. You know, you measure on the fluctuation, yeah. Well, if you put too much, yeah, this will become additional offset. The RS1 and RS2 will be additional offset in the signal. You remember offset? What is it? Nah, this is the use of course theory is like this, but you know the correlation. This will increase offset, etc. Understand or not, Grace and Andy? Yeah. Good remark, Ezra. Any other question, Anjali? One question, short question.
Can you go to the slide where you compare before and after stitching?
Previous one, ya.
Where?
Itu tuh yang, ya.
No, yang pas di akhir-akhir yang ada sebelum stitching sama before stitching yang ada few things itu, bukan yang angka-angka. After the stitching.
Yeah.
Okay.
So this here you said prior to stitching, residues of HBN and BMPFA weren't formed, but what about after the stitching? What happens to the residue?
Actually, that's the problem in our experiment too. Kayak we are supposed to use the residues the residues formed after the filtration, but then there are no residues formed at all. Then we try to increase the concentration of the the sediment inside the distilled water or the isopropyl alcohol. Kan before it's 40 milligram inside 40 milliliter. It's inspired from Kakristo's paper before. Then we tried, okay, let's try 80 milligram in 40 milliliter. Then we do the sonication and centrifugation. Also, the centrifugation speed is also increased. Like previously, I think it's 500 RPM. We try to increase it more like to 1,500 and then to 3,000. And then to 3,000, but there isn't any residues formed at all. Gitu. So I think it's because I don't know if whether the HBN sediment could be used or not. Because it's not like in solid form gitu, itu kayak masih rada kental gitu. But we use the supernatan in instead of the residue. Actually like there are residues kayak yang di air-airnya itu kayak kelihatan residue gitu. Cuman kayak I don't know why, but after we centrifuge it, it won't get separated. That's what also took a long time for us. Jadi kita stuck di situ, and then the last part we couldn't maximize the result. And that's one of our problem gitu.
Okay. So now since there is only one single milestone left, I think you choose HBN only lah. So
sorry sir.
Choose HBN only because BN and PVA it's not proven yet. I don't know why you come up with the idea of adding PVA, polyvinyl acrylonitrile. Is it proven to be adding the infrared absorptivity? Is it or not?
There's a paper.
You don't put the paper also in the presentations. I don't know if this is your original idea or from somebody else. Maksud saya, the idea is to have a develop, to have, even with HBN, the novelty is already there.
Okay.
And it is previous group also already proven, also very qualitative and very initial proof that it absorbs infrared and some changes occur qualitative. Actually, it's easy then. Your group task is to continue and then to do more quantitative measurement of what the previous group had done. Quantitative calibration of the cnt-coated thread, quantitative calibration of the cnt-coated thread sewn into the HBN fabric, put into the bolometer region, and now above them you put temperature, heat temperature, infrared, something like that, with the controlled experiment setup. If you can have that calibration chart, quantitative calibration chart, that is already a lot. Maksud saya, don't waste time untuk mencoba hal-hal yang baru yang belum terbukti. Ya, sama juga untuk grup 1 juga. Yang belum terbukti itu, yang dari previous group saja sudah jelas itu mana yang mereka itu belum selesai. Itu aja, itu selesaikan. Kalian yang jangan terlalu tambah, karena because of time, we don't have much time to tinker around, to move around, to try new material. Nah, nanti kalau new material tadi ada masalah residu, masalah centrifugation-nya berapa, harus optimisasi lagi. Right? You can try later in next semester, for biomedical instrumentation project. For now, finish up what the previous group have done, and they have done quite many, but they haven't also finished. Like the quantitative calibration is still, they are very good already. They do the calibration, tetapi it's not perfect yet. Yang ini yang infrared, they did initial, they put their hand above, and they move their hand out. There is some small change, but it is not yet perfect. So why don't you amplify that small change so that it has become a readable signal? Itunya konsentrasi di situ gitu loh. Kan sejak milestone 2 saya sudah ngomong. ke both group, jangan terlalu you I know you are all smart, you have many ideas, tapi masalahnya kalian kan tidak pengalaman eksperimen. Pengalaman eksperimen kalian paling apa? Semester 1 ya. Begitu masuk semester 2 sudah pandemi. Ya, itu ya. Setengah semester 2 sudah pandemi. Dan kalian pegang itu tadi masih nggak tahu kalau kontak antara multimeter dengan itu bisa wiggle and then to change the resistance. Kalau biasanya when you measure resistance, the resistance is very big, the small is very small, not significant. But now maybe with the cnt-thread, even slight movement may cause significant change of the resistance. Jadi hal-hal seperti itu, experimental feelingnya itu yang dibangun dulu, it's more important rather than developing new ideas. And then if you develop new ideas, you have to prove. But proving new ideas require a lot of time. Understood? So improve, focus on improving the previous senior, your previous senior group. Consult with them, if possible, extensively, intensively, what to change. So ask them to get involved in your experiment, and don't hesitate to ask them. Yeah, because even though they actually did not do their experiment also by themselves, it's by Sam Andrew, but at least they got some insights into, and if judging from their reports, not completely bad, even though not yet for the first group PCR, the previous group, the problem is also not yet integrated. They did it also individually, but now your task will be to integrate them into a single device. And I don't ask PCR yet. I ask microfluidic thermal cycler, right? So no need to put, not yet putting real DNA sample, but you have to prove that you can regulate temperature within the chamber, small chamber of microfluidic, fabric-based microfluidic device. You can increase the temperature, you can measure the temperature, and then regulate it using RD. That is the goal. Jangan coba yang macam-macam dulu. I don't know with zigzag, who come up with that zigzag schematic. Tapi lebih susah lagi. Terserah. Yeah, similarly with the second group also prove that they have proven actually the first group there is a trend, it might work. They can initial result it might work, but still very qualitative initial result. Now your task is then to make it with thorough experiment more quantitative result. But do not introduce too many new things into the parameter. Selesaikan dulu yang ada gitu, paham nggak? Jangan punya terlalu banyak ide gila, tapi kalian sendiri tidak bisa membuktikannya, ide-ide kalian. Jadi masalahnya itu, punya ide itu harus bisa dibuktikan, bukan sekedar ada ide, banyak orang banyak ide itu mudah. Tapi yang bisa melakukan ide itu, yang bisa membuktikan ide itu tidak mudah. Melakukan eksperimen untuk membuktikan setiap ide itu dengan baik. Questions?
Mungkin nanti buat ngukur kayak temperature-nya, misal kayak di 30 degree, 40 degree, 50 degree, kayak can we just put the bolometer like inside an oven, we like put it there
Ya,
gitu?
gini, kalau di oven itu kan
Takutnya ya
seluruhnya. Kalau sebagai bolometer tidak bisa. Itu untuk kalibrasi si cnt-thread-nya sebagai temperature sensor. Tapi sebagai bolometer kan radiation. Kalau kamu masukkan ke oven kan sebagai itu thermal conduction yang terjadi dan convection di dalam normal. Jadi harus pakai a regulated heater gitu. Yang kamu bisa ditaruh di atasnya bolometer itu. Within what distance you also measure that distance, because the absorbed infrared will also depend as a function of the distance. Misalkan kalian punya heater yang bisa kalian regulate 37 derajat. Regulate 37,5 itu yang ditaruh di atas bolometer itu.
Oke.
Ya, terserah apa itu. Kalian buat pakai solder kayak pakai apa kayak heat source. Pakai badan temperatur kalian sendiri kan, tapi kalian nggak bisa regulasi. Kalau yang the first group itu mereka taruh tangannya sekarang pertama di dalam heater atau di dalam apa gitu ya. Dipanasin tangannya. Terus ditaruh dia itu. Jadi kan lebih panas ya 37 derajat. Terus yang normal 37 derajat. Terus ada yang taruh di tangannya si Sam itu ditaruh di kulkas dulu 4 derajat. Langsung ditaruh di atas volumeter. Ada perubahan nggak gitu. Tapi itu kan very kualitatif. Masih initial result saja, initial trend. Nah, kalian tugas kalian berarti bagaimana membuat itu lebih kuantitatif. Gitu.
Kalau untuk characterization thread-nya sendiri berarti kayak apakah kayak thread-nya benar-benar kayak habis selesai coating kering terus thread habis itu ya kita coba konekin pakai wire biar tadi resistance-nya nggak berubah pas diukur terus taruh di oven, atau kayak kita
Ya,
stitch
bisa
dulu
seperti itu
cotton
sebagai
fabric.
pengujian sebagai thermistor. And I think that you can read that in the previous group report. How they characterize it as thermistor. Ada persamaannya juga kan mereka.
Ya.
Untuk itu
Because,
persamaan thermistor itu. Jadi mereka taruh, saya lupa, saya belum baca ulang.
Tapi saya takutnya kalau jadi kan kayak sebelum di stitch sama sesudah di stitch kan resistance-nya beda, makanya kayak saya takutnya kalau kayak misal kayak kita ngukur, soalnya mereka kalau nggak salah tuh cari beta value-nya.
Resistance-nya itu theoretically should be the same. Kenapa berbeda? Karena kan tidak ada no electrical conductance in the cotton fabrics.
Tapi kayak peel off gitu ya. Saya
Ya,
nggak tahu ya.
tapi
Maksudnya kayak
peel off-nya
yang
itu
udah
dia tahu,
dieksperimen.
oke. Because of the peel off, ya. Tapi kan tidak banyak. Berapa itu kan diukur. Memang itu kekurangannya dengan metode coating yang sekarang, ada peel off ketika after stitching.
Takutnya naik gitu, terus kalau beta value-nya diukur dari kayak thread-nya doang gitu, nanti buat ke
Ya
depannya
bisa,
kayak
jadi kalian ukur juga berarti setelah sew.
Oke, berarti ya
Setelah
dua-duanya
dijahit.
aja lah ya, biar
Iya.
kelihatan.
Tapi itu sebagai thermistor kan, sebagai thermistor.
Ya.
Bukan sebagai bolometer. Sebagai bolometer harus tapi bukan kayak gitu tadi. Yang lebih regulated lah, apa heater ditaruh di atasnya dan kalian jaga jaraknya berapa, dikontrol, simulating for example thermal gun itu. Cuma kalian bukan pakai. Jadi kalian harus mensimulasikan suhu tubuh sehat, suhu tubuh demam, suhu tubuh kedinginan berapa, hipotermia, hypertermia. Terus kalibrasi. Nah, itu di situ berarti letak kalian mesti mikirnya di situ. Jangan ke BNPVA nambah-nambahin masalah.
Oke.
Terus apa lagi tadi? Memperpanjang thread-nya lagi, nambah masalah juga.
Kalau pakai wire gitu terus kayak kita masukin kayak yang tadi kayak mau nyoba karakterisasi gitu kan kayak masukin oven, itu apakah nanti pengaruh gitu resistance-nya dari wire-nya?
Ya, wire-nya tuh ada pengaruh, tapi kan dia mestinya tidak begitu besar.
Jadi ya nggak apa-apa.
Kalau conductive wire itu temperature koefisiennya tidak sebesar thermistor, theoretically ya. You have to check.
Okay.
You have to put into account also that the resistance change from the wire due to the temperature change. Tapi I think small, the NTC or PTC-nya small. Tapi ya please check again. Ya buktinya kan wire itu kan juga dipakai biasanya ada range sampai they are used in hot temperature region, also in cold countries they are also used. Oke, grup 2, grup 1 tidak ada pertanyaan. Okay, so please fill in online attendance second session 0721, the OTP is 0721. So after this, it's just the final presentation. Yeah. Final presentation will be done during the final exam week. So no written exam for you. It's from this project. But then I will assess individual understanding as well of the project. Yeah. So yeah, like this now, right? knowledge about electronics come out, knowledge about physics also come out, knowledge about calibration curve also come out. So you have to really understand what you are making, what you are doing in your project, each of you. Ya, bukan hanya satu orang saja, semua sebagai grup paham, individually juga paham, karena nanti we will also